cloud infrastructure setup. So after you must have done the deep dive into what you need to do. So you will then go to the more technical side of things by setting up the cloud infrastructure. And this is why it's very important for you to be conversant with your cloud providers like
Hey, if I hear that rubbish again,
GCP, AWS, and Azure. This is where you will create and set up a virtual machine. So a virtual machine is like a computer that lives on the cloud. This is where this is where your large language model would live. So after you must have set up your virtual machine, then you can deploy your local LLM instance on the virtual machine. And the tools that you would require in this phase are Google Cloud Platform and Linux. Linux, because in the VM there is really no UI. You can't click on things. So you basically have to write some scripts or some Linux to communicate with the computer. Like maybe you're, creating a directory or you're moving a file. It has to be CP or MV or, CD, all of those things. So that's why I said Linux might be something that's important for you to know as a machine learning engineer. So after you've set up your cloud infrastructure, then you go to the API development. So you have your large language model sitting in the virtual machine in the cloud. How do services and applications within the company communicate with this large language model? So the API is basically that communication layer between your services or products within the company and the large language model that sits in the cloud. So what are the things that you do? The activities that will be required in this case would be setting up a code repository, obviously, because you are doing some software development at this point. You are developing an API to communicate to your locally hosted LLM. Yes. So that's basically the communication layer between the LLM and the services that would be that would consume, this LLM's knowledge. You'll be writing test cases, obviously, because this is more dev work, and you'll be setting up CI/CD pipeline because of collaboration and automatic deployment of the API if there are changes to the repository. So the tools that you require for this phase, things like GitHub, obviously, for collaboration, Git for, your commits and, pushing your commits to GitHub, Python, language of choice for machine learning, basically, Flask for API, PyTest for testing, and GitHub Actions for CI/CD. Then there's authentication and monitoring. So authentication and monitoring is basically, securing your APIs so that people from the outside cannot attack or use your service. So yeah, you set up an authentication workflow and you set up login and monitoring. So Grafana for login and monitoring, JWT authentication. Actually, in my case, so JWT authentication is implemented on API Gateway, and then my LLM API is hooked up to API Gateway. So yeah, it uses JWT authentication. So after you must have done all of that, you want to be able to show your work to the larger company or to the stakeholders. So you need to develop a proof of concept. So in my case, since the project was self-hosting an LLM, phase one of the project was self-hosting an LLM, a proof of concept would be a small application that would allow, stakeholders to interact with this LLM that we've self-hosted for our own use case. So activities involved in this was developing a minimum viable product. As a machine learning engineer, you typically not build front-end applications, but one library would help you a lot when you're building proof of concepts, which is Streamlit. So Streamlit allows you to build a front end for your data-related use cases. So it comes in handy when I'm building MVPs. Containerization, because for your MVP, it's a small app, so you need to containerize it and then deploy it. Setting up CI/CD pipeline, DevOps, and the MVP app deployment itself. So tools, GitHub, Git, Python, obviously like software engineering related things. Streamlit for the front end itself, PyTest for tests, and GitHub Actions for CI/CD. Then project documentation. So like I said, you might be one of a few people in the company that actually understand what it is that you've done. And obviously, this project needs to be communicated to stakeholders themselves. So you need to be able to write down everything that you've written, and you need to be able to explain the technical bits in a way that non-technical stakeholders can understand. And also for the sake of, the team itself, writing down your work would ensure that your colleagues can easily jump into a project and help out if they need to. So activity overview, documentation on software architecture, of, data flows within your app or service. Documentation on system design, which cloud infrastructure did you put together to be able to serve this product in a production environment? Documentation on use case. What particular use case did you build that particular feature for? Yeah, and this is where you talk about edge cases and things that you do not expect the service to be used for. So everybody is up to date concerning that. And for tools, I use Miro a lot for my technical diagramming. So that's good for software architecture and system design diagrams. Confluence and Notion, the company Confluence and Notion or Notion page, that would be used for, storing the documentation itself. And also GitHub. So the README section of your repository could be used to store the more, technical information for a technical audience. And finally is the stakeholder update session, which is where you present the work that you've done to the stakeholders and hand over the MVP to them to interact with. And the tools for this would be, presentation slides. So you'll be doing something very similar to what it is that I'm doing right now for so that they can understand the work that you've done and what the feature can do and cannot do. And this is where, like I said, you hand over the MVP to them, show them a demo on how to use it and the likes. And that brings me to the end of my session. Yeah, small hiccup would not record in the first few minutes, but yeah, that is the end of the session. And now I'm open to answering any questions that you might have. And just to remind you all that, three of the most active attendees would be getting a giveaway. Again, that's a message from the organizers themselves. So now I'm open to questions. If there are no questions, be forced to answer some arbitrary questions that I have written down. Just some questions that I feel like I needed to have answers to when I was transitioning to the field as well. So, Asu has said, please throw light on GitHub. Thank you for this question, Asu. So, GitHub is basically like I wanted to say it's a repository for your code, but that's exactly what it actually is. So, but it's basically like a platform that allows you to store your code in the cloud in like in a place that's not your local computer where you're working. So some people use it for, a kind of backup for their code, but when you're working in a team, that's when you really see the power of GitHub. So it's a collaboration tool, basically. It's where different developers working on different computers can aggregate their contributions on a particular project and actually accept and reject lines of code that was written. It's also a place where your application can be tested before you deploy your application. And it's also a place where you can deploy your application if you are using GitHub Actions for CI/CD. So yeah. So that is what GitHub is. And it's something that you really, 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 really need to be conversant with because it's a tool that you use every single day. And I hope that answers your question. So the second question, you're welcome. The second question is, can you shed more light on the open source route? I'm sorry. Okay. Can you shed more light on I'm sorry, trying to see. Can you shed more light on the open source routes to getting into data science career? Yeah. So I feel like contributing to open source should come after you must have after you must have learnt the rudiments of things. So open source contributions is basically you contributing to an open source project. Say there's a data science library that you like to use, or there's an impactful data science library out there that you use for one reason or the other, and you appreciate it so much. And you want to you want to be one of the contributors to that particular project. So you go on, GitHub, again, why GitHub is very important. And then you go to the project page, you could fork the repo, you could then make changes and you could raise an issue, create a pull request, and contribute to that particular project itself. The reason why I like this for beginners is because it demonstrates a passion for the field. Again, if you are transitioning to the field of data science, you want to be able to demonstrate to recruiters or people on the interview panel that you are really passionate about the field. And contributing to open source is one of the ways that you can show them that dedication to the field, that you really care about this field rather than, just making money or getting income from the field itself. And it doesn't even have to be something technical. It could be documentation changes in the project itself. It could just be you changing a typo on, the README, or you expanding on the doc string to make it more, explanatory. It doesn't have to be actual code changes in the project. So it's just to show that you are passionate about the field. That's why I always recommend that beginners could contribute to open source. Next question. Can Nifemi said, can you please throw more light on Linux? Is it the OS or an application? So Linux is like it's an OS, yes. But it's almost like if you're using a Windows PC, and you're using the command prompt, it's something like that. Or if you're using a Mac and you're using your terminal, it's something like that as well. So the reason why I'm not saying it's a must. I'm just in my experience, that has been very useful. Because if you're setting up virtual machines in the cloud, there is no user interface. You can't click on anything. It's a computer in the cloud, but it's basically just if you're trying to interact with it, it's just the terminal that's there. So you have to be able to, write Linux to communicate, to do things on that computer in a way. So if you are creating a directory, if you're creating a new directory, it has to be mkdir to create the directory. If you are moving the file, you have to write cp, the file name, and then the file location. So you can't click and you can't drag things in the VM. I don't know if there are VMs that you can do that, but in my case, in my experience, the common VMs are just like a very big terminal. That's what you'll be able to interact with. So it might be important for you to know some Linux, but it's not something that would be hard requirements during interviews or anything like that. No. Uh, you're all welcome. So let me go to more. Okay, so the older questions. So Olakunle said, is there room for improvements in ML libraries such that they might not need GPUs? Hmm, that's a very interesting question. I'm not sure. So the reason why we need GPUs for like ML related tasks, mostly during training, also during inference sometimes as well, to be honest, is because of the large amount of, calculations that a large amount of computations that go on when you are training a model or using a model. So yeah, it depends. If I reckon if CPU infrastructure improves significantly in future, maybe we won't don't need GPUs, but then that would make CPUs really expensive. So until we can get the cost of that technology down, I think GPUs are still very, very, very important.
Mano, como é que é só pelo que é does that go?
So, can you shed light on getting employment in data science by open? So I think I have, and I think I answered that. Can you please share the resume? So yes, I was talking about a minimalist kind of resume. I would make sure I pass that across to the organizers after this call. So let me see. Yeah, I think those are the questions that we have on the chat. So there's one question I expected someone to, do you need say a master's or a PhD to work in data science? No, I think it's a nice thing to have. But in my experience, most people in the field of data science also transitioned from other fields. So they don't have a data science or a master's or PhD in data science or machine learning or AI. Even in my case, although I do have those credentials, I have a master's in data science and artificial intelligence, but I actually landed my job before I finished my master's. So I don't think that factored too much in the decision making concerning me getting the role. So yeah, and let me look for one more question just to be thorough. Uh, so at there, okay, yeah. So this is an important one as well. So for data science related roles, is it mostly technical interviews or situational interviews? So yeah, I think it's a mix of both. If you are interviewing with big tech companies, I think you do a lot of technical interviews because I know Reddit does technical interviews for machine learning. Google does technical interviews for machine learning as well. The medium to small companies might not do technical interviews, but for them, you should expect a lot of situational, scenario-based interviews where they ask you, oh, if you have this data and you have this many missing values, what do you do to this column kind of question? So yeah, those are the two questions that I wrote down. And yeah, thank you guys for asking questions as well. I didn't need to go through my list of questions. So that's nice. So just before, I think we've spent enough time on this call. We're actually over by 3 minutes. So just before we leave, just to make sure that there are no other questions. Nope. So if that's the case, then this is me. This is where, we would end the class. And this is me saying good luck to everyone concerning the transition. A few years ago, I was like you guys as well. And this is me just telling you that you can do it. It's doable, it's possible. And I wish everyone the very best. All right. Bye.
Thank you, sir.
You're welcome.